Lesson 5, mass spectrometry. So we've done the theory of mass spectrometry, where we've used a time of flight or looked at the time of flight mass spectrometer. So mass spectrometry can be used, this is your time of flight mass spectrometer, can be used to determine the molecular formula of a compound. In other words, how many atoms, say for example of carbon, hydrogen, oxygen, whatever, are in there. Now just to jump to this bit, there's two different kinds of mass spectrometer, or rather there's two different levels of accuracy. There's something called a low resolution mass spectrometer, which is broadly a cheaper version, and it can't measure to any decimal places. However, you can go up to high resolution mass spectrometry, where it's a much more expensive and sophisticated machine, and it can measure to 5 decimal places, and that can be useful to determine the molecular mass of substances with similar relative formula masses. I'm going to demonstrate what that means. So we've got C4H10 and C3H6O. I want you to determine what the relative formula masses of each of those are to no decimal places. So using carbon as atomic mass 12, hydrogen as atomic mass 1, and oxygen as atomic mass 16. So what is the relative formula mass of C4H10? That's 4 times 12 and 10 times 1. And what is the MR, the relative formula mass of C3H6O? 3 12s, 6 1s, and a 16. And you should find out that they're both the same. So now if you used a low resolution mass spectrometer, you couldn't distinguish between whether you had a sample of C4H10 and C3H6O because it can't measure to any decimal places at all. So now if we look at moving from a low resolution mass spectrometer to a high resolution mass spectrometer, that a very expensive one will measure to 5 decimal places, now things change, because a carbon is still a 12.00000, but a hydrogen actually isn't 1, it's 1.00784, and an oxygen isn't 16, it's 15.99999. Will you tell me what the relative formula mass of C3H6O is to 5 decimal places? And similarly, C4H10, 4 multiplied by 12.0000, add 10 multiplied by 1.00784 for the hydrogens, give me the relative formula mass of this. And now, to 5 decimal places, you will find out that they were different. So you can distinguish between C4H10 and C3H6O, not using a low resolution mass spectrometer, because it doesn't measure to any decimal places, but you can if you use a high resolution mass spectrometry. If you use a high resolution mass spectrometer, it will measure to 5 different decimal places, and I can tell the difference between the relative formula masses of each of these two compounds now, and tell the difference, tell me whether I had C3H6O or C4H10. Work out the missing numbers.